In this example, you're being asked to identify the nucleophile and the nucleophilic atom of that nucleophile. You're also being asked to identify the substrate and the leaving group of that substrate, as well as the electrophilic carbon atom of that substrate. So here we have two species on the left side of the arrow. One of these is a nucleophile, one of them is a substrate. Let's start by identifying the leaving group. Okay, so between these two species, there's really only one good leaving group, and that's this bromine atom here. The leaving group is always on the substrate, which means this species here on the left is the substrate. The leaving group of that substrate is the bromine. And the leaving group is always bonded to the electrophilic carbon atom, which means that this carbon here, which I'm about to dot in red, that is the electrophilic carbon atom of the substrate. That is the carbon atom that gets attacked by the nucleophile. Okay, so we've identified those components. The other component here, this species here, this must be the nucleophile. Now, I'm showing the cation there, the sodium cation, but that has nothing to do with the actual reaction. So you have to keep in mind that those cations, they are there. They're not often drawn in when you're looking at these reactions on paper, but they're still there. The real nucleophile is that nitrogen. I'm going to redraw this below. So the nitrogen there still has the two hydrogens bonded to it. Now up in this actual starting material, I'm going to show those two lone pairs on nitrogen. Remember, they're not always going to be drawn in. It's kind of a lazy thing that chemists do, but they're still there, and you have to realize they're still there. So those lone pairs are still there. When this thing dissolves, it actually gains more electrons, the electrons between the sodium and the nitrogen. That is where this negative charge comes from. So this species here is the actual nucleophile. The nitrogen is the nucleophilic atom. That is the species that's going to donate the electrons to the red electrophilic carbon atom and kick out that bromine leaving group. So we've identified all the components here, but while we're here, let's just predict what the actual product of this reaction would be. Okay, so we know that nitrogen atom is going to donate electrons to the red electrophilic carbon atom, and it's going to do that from the backside. Backside attack is how an SN2 reaction occurs. That means, and you got to use your imagination here, since I have the hydrogen on a wedge, it means it's sticking out of the paper. Bromine's on a dash, that means it's in the paper. The nitrogen is going to approach from the backside, meaning opposite the leaving group, which means the nitrogen is approaching that red carbon from outside of the paper, opposite the leaving group. When it bonds to the red carbon, that's going to kick out the leaving group bromine. That proton, that hydrogen on a wedge, it's going to repel away, which means it's going to end up inside the paper. So let me draw that same 4-carbon chain here. But now I'm going to draw the hydrogen on a dash. And what is going to be on a wedge? That's the nitrogen that just added, and it still has the two hydrogens, and it still has a lone pair. This would be the product of the SN2 reaction. And of course, the bromide left is a leaving group there. I'm not showing the lone pair electrons on there, but they're still there. So that would be the product of the SN2 reaction. You'll learn a little bit later, we're not there yet, but this won't be the only product. There will be some side products, something called an E2 reaction. We're just not there yet, so I'm not going to show that yet.